unas palabritas. Hola a todos, hello everybody. It's a big pleasure for me to present the speech Professor Bruno Siciliano as a colleague and also a long-time friend. As you probably know, he's a professor of control and robotics in the University of Naples, Federico II. It's one of oldest Italian university, founded in 1224. A lot of culture, a lot of knowledge. He is coordinated of the Prisma Lab. It's a world-famous robotics research team. Naples and Madrid are two connected countries, two connected cities. Especially through the King Carlos III. King Carlos III was the king of Naples and Sicily for 25 years, and then they moved to Spain and was the king of Spain during another 30 years. It means we have a very good connection, friendship, and tradition. And Carlos III was one of the best Spanish kings that introduced Italian culture in Spain. Bruno is one of the outstanding roboticists. I will not list it. His CV, you can find it easily in the web. But I want to highlight that this is a fellow of IEEE, ASME, and also IFAC. He was a president of Robotics and Automation Society from 2008-2009, and he's very good writer, very good writer. His book, Robotics, is one of the first good robotics textbook, and also he's editor with Osama of the handbook of robotics, and just now he told us that he will publish very close 4 new books. He's a very good writer. His research topics are very broad, and he's specialist, of course, in control, dynamic manipulation, legged robots, medical robots, etc., etc., etc. Last but not least, I want to thank University Carlos III for help for this organization, also to Robotics Lab, and also to European Digital Innovation Hub of Madrid region, that is our sponsor and help us to make this kind of meetings. Also to a Spanish technological platform on robotics, ISPAROB, and for Madrid Robotics Hub, RoboCity. And nothing more. Bruno.
Okay. Can you possibly switch to my laptop? Yes, okay, sure. Yes. I hope did you manage the audio to work? Okay, so we are in good hands. Okay, Carlos, good afternoon. Normally we would say morning because this is before lunch, but the British would say good afternoon because, technically speaking, it's afternoon, after 12 o'clock. Yeah, it's nice to be here. I've been visiting various labs. Also, I've been visiting this beautiful campus in Leganés, and I've been impressed. I was telling Carlos that this morning has been a treat for me because I remember the good times when I was an assistant professor and I was traveling a lot. And each time that I was going to a conference or to a meeting, I would take advantage of visiting labs and meeting people. So this morning, you really made me a nice treat, just because I met a lot of enthusiastic younger colleagues of Carlos and also postdocs and PhD students. So it's really nice. And also Madrid and Spain is very much linked to southern Italy, to the old kingdom of the two Sicilies, just as like before, the crazy Italians wanted to be united. Okay, I'm very southern, just as like, okay, so I agreed with Carlos to give a general talk about what's happening in terms of, I would say, a sort of scientific contamination across different fields. And robotics and AI and communication technology like 5G are examples of this kind of contamination. But actually, you said a lot about University of Naples Federico II, which is the oldest public university in the world. In Italy, we have 2 older universities, namely Alma Mater Studiorum, University of Bologna, which is like 900 years old, and also University of Padua, who is like 2 years older than us, but they belong to the church, so they were not independent. Also, we are the oldest engineering school in Italy. This was King Gioacchino Murat. He was a general of Napoleon army in 1811. This is like the French format of like les écoles françaises. So he founded the School of Bridges in 1811. So 12 years ago, we celebrated 2 centuries of engineering in Napoli. It's like, so these are the figures, 4 schools, 23 plus 17 research centers. We are 26 departments, and 2023 has been a fantastic year for Napoli because we were champion of Serie A, but also has been a fantastic year for University of Napoli Federico II because 12 out of the 26 departments were chosen by the Minister of University to become departments of excellence. This is a 5-year project with a 10 million grant, which is like really, awarding the excellence in all the public departments of universities in Italy. And every 5 years, they select 180 departments. So, 12 out of 26 means almost that 1 out of 2 researchers in Napoli works in the Department of Excellence. So in terms of the university, we are second in Italy, in terms of number of departments of excellence, after State University of Milano. They got 13. But we are the first in engineering. 4 out of 5 departments in engineering are departments of excellence. So these are the numbers. I don't need to spend much time. And a few words about my own department, Electrical Engineering and Information Technology. We were one of the 5 departments of excellence in the previous 5 years. And again, we've been the only one of the 2 departments who have confirmed to be departments of excellence in the next 5 years. We have a quite broad field of interest. You might be familiar with, I'm a professor of control. All professors in Italy, they are clustered into what they call scientific disciplinary sectors. So we cover 18 different fields. So it's like control. Robotics is part of control, but it's not only in control, because robotics is also in electrical engineering, it's in mechanical engineering, it's in computer engineering, and so forth. So these are the figures. We are the largest engineering department, and we have 6,000 students out of a population of, I think, about 70,000. So it means that 1 every 11 students in the whole university studies in a course in our department, and a number of 2 research doctorates, 80 PhD students, and so forth. And also we've been quite active on the so-called academies. So we are the only academy, the only developer academy, for instance, by Apple. Apple chose Napoli to be Federico II to be the only academy in Italy. So I want you to get a dive into the field of robotics. I know that many faces in this room are familiar with robots, but this is a short version of a video which I edited from the Spring Handbook of Robotics, and it shows in 5 minutes what are the coolest, I would say, the funnest applications in terms of developments of robotics in the last 15, 20 years or so. So I hope the audio works. Yes. So you saw many robots at work in a number of applications, and I like to be a little bit, just following the taxonomy of our field. So robotics is defined in the scientific community as the intelligent connection of perception to action, which is the same feedback principle which it just inspires our human life. So in the end, you have three main ingredients in a robotic system, namely intelligence. I'm a control guy, so it's like I'm devoted to design, just intelligent control systems. But also you have the sensory part, the perception. So I'm thirsty, I want to get this glass of water. So I localize the bottle, then I just move an action. So there's an actuation and a perception, which is combined through the intelligence, and then I can drink the water, I can feel the bottle of water, if it's plastic or if it's another material. So you have actuators, you have sensors, and then you have control. So often, I was discussing this morning also with Carlos, but this is like, if you read any article in the media about AI, just pay attention to the fact that the iconic image of any article published on AI is often a humanoid, a robot. Why is that? Because in AI, we do have the intelligence, which is at the basis of the definition of robotics, the intelligent connection of perception to action. So if we want to give a broad definition of AI, we can speak about computers mimicking functions and logics of the human mind. So we do have the intelligence, but also we have the sensor, the perception. If you take Alexa, Siri, just as like, or during the COVID pandemic, we learn how to do like smart working. So we were using like intelligence, like communication, and also sensory data. Now, this is one first example of cross-contamination between robotics and AI and other fields. And this is the case of neuroscientists. They made an interesting study, which is called the cortical homunculus. What is this cortical homunculus? Is a sort of parasitic view of an homunculus, and the size of the sensorial organs is proportional to the importance of the organs. So people would expect that vision is the most important sensor. Probably not. Tactile, touch, is the most important sensor. So this homunculus has two big hands, meaning that the sense of touch is crucial for human life. So we have intelligence, and then we have perception, and then we have the weight of each sensor in deciding action, in performing tasks in a more or less intelligent way. Now, I've been privileged to do a PhD in robotics, and as I was heavily influenced by my teenaging time, in which I was like really eager to read books by Isaac Asimov. He's like the most famous science fiction writer. And if we speak about AI, robotics, Asimov, and engineering, we can discover some interesting, just positions. So you can develop, take ChatGPT, take any kind of AI algorithm, then, just it's like the impact on humans as some sort of effects. What about the impact of engineering? What about the impact of robotics? Since I mentioned Asimov, you probably know, being in robotics, the three fundamental laws of Asimov, which establish a sort of relationship between the human and the machine. Just a machine, the robot must not harm the human. So the message I want to share with you this morning is that we cannot leave to AI decisions which may have safety, moral and legal consequences, because we cannot assure the outcome. So why is that? Because of the physical. I was discussing, just through the various visits this morning with Carlos and the various labs, because if you certainly remember that Deep Blue was a computer that defeated the world champion of chess. Now, do we have a machine that can defeat human, a physical machine? No. This is the well-known Moravec's paradox in the field of AI, robotics, and neurosciences, that it says, verbatim, that it is relatively easy to make computers perform comparable to adults in intelligent tests or playing checkers, but it's impossible to give them the perceptual motor skills of just a 1-year-old. So we are still at the infancy of the physical AI. So here we have a big challenge. On one hand, we can summarize the intelligence just by one word, cognition. Now, just relying on the importance of the physical contact between a robot manipulator, between a robot and some object, the feature which probably best characterizes the fact that there is a robot is the manipulation. In the end, you use a robot because you want to manipulate, you want to grasp objects, you want to do some physical action. So this is the big challenge. And this big challenge between body and mind has deep cultural roots dating back to more than 2,000 years ago, to the time of the Greek philosophers. Aristotle, he was convinced that the human is a superior creature, and it's the intelligence of the human that allowed the human to interact with the physical world, with the real world. On the other hand, Anaxagoras was of the opposite theory. He was a believer that humans develop their intelligence through the possibility of manipulating, of touching. Now, take a child in the first months of their life. What do the children do? They grasp all the objects and they bring the object to the mouth. And the parents get worried because they would eat, maybe the smartphone or the credit card or a key or something. Why is that? Because the children, they explore the world according to the concept of the cortical homunculus. They explore the world because they touch. So a 3-month child has not the same level of intelligence of like a 2-year-old or 3-year-old child. So basically, the Anaxagoras was for the children. So basically, you interact with the world, you manipulate, you grasp the object, you bring to the very essence, they bring to the mouth, but actually they want to bring to their soul, to their mind. That's the gesture. I discussed this with neuroscientists. So this brings me to a very important concept, which also I've been discussing this morning during my lab visits, is the concept of embodied cognition, is the concept of embodiment. So not only is there a sort of neuronal intelligence, just giving the commands, but also there is a sort of peripheral intelligence, which is ultimately due to the shape of the hand with the fingers, the phalanxes. So this is a local intelligence, is an embodied intelligence, which allow the children to develop their skills and also their mental intelligence. So if we capture this sort of dichotomy in a sort of proactive way, we come to the concept of physical AI, of physical artificial intelligence. And other than wasting time in a sort of cultural battle between the AI experts, the AI purists, they look at us, the roboticists, as one of the N applications of AI. Then you should explain to me why, if there is a media article about AI, there is the iconic image of a robot. And we, the roboticists, we look at AI as a sort of one of the enabling technologies. So other than just quarreling between the two communities, I think the big challenge is found at the intersection of robotics with AI. And as we learn from Moravec's paradox, implementing some physical AI algorithm is much, much harder than Alexa, Siri, ChatGPT, whatever sort of AI algorithm may we wish to use. And the deterministic use, the blind use of AI is very dangerous and can have some physical consequences which concern with the safety, the legal, and the moral duties of those that utilize the technology. So I teach a course about robot interaction control, and usually my first class in this course, I show this movie. This is almost a century ago, 1930, modern times, Charlie Chaplin. The poor Charlot is alienated to be fed during his lunch break out of an 8-hour working shift, like 4 hours, lunch break, 4 hours. And the engineers developed this fitting machine, and it's the human to comply with the machine, with the spatial temporal sequence of the various dishes to be fed. It's the rigid sequence again, so it desperately tries to comply. So this, what is the message? And often in the cinematography, we've had precursors of technology to be developed like 20, 30 years later. So do we really want a fully autonomous machine? So if we develop this concept together with a colleague and a dear friend, Antonio Bicchi from University of Pisa, he's the current president of the Italian Institute of Robotics and Intelligent Machines, we wrote a comment on Nature Italy, and we introduced a new field, a new discipline across robotics and AI that we call interaction technology. So this is the natural trend. So we come from 2 or 3 decades of ICT, or if you wish, IT, information technology, in which we have the intelligence, we have the perception, but there is not the physical action. So the acronym is intentionally made out of 3 letters, IAT, not only to disambiguate from information technology, but also to stress the importance of the physical action, IAT. So, and for instance, I just mentioned the project of Department of Excellence in our department. So we, the winning project, the one which was awarded by the minister, is a project about IAT, interaction technology. So I know that you've been very active in Industry 4.0. You have a master, if I'm not mistaken, so I don't need to explain the concept of Industry 4.0 and the concept of cyber-physical system. I just want to recall what is considered to be the icon of Industry 4.0, which is the cobot. It's a human-robot cooperation. So it's a robot which is intentionally designed and controlled in such a way to safely interact and to share the same workspace with the human. So this is an old video. Probably some of you, they know this video already.
Even you think. We could just show the robot what it's supposed to do. Listen, imagine this is our workpiece, and this is our robot.
Okay. It's insensitive, it's deaf, dumb, and blind.
Yes, but it moves with great precision. Now, if it's supposed to drill holes here, I just show it the positions, starting here, 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 and finishing here. The robot remembers the coordinates and repeats the procedure, and that's it.
Whoa, that thing is dangerous. It belongs behind a fence.
Not if it's equipped with an anti-collision system. Huh? And if we give it a soft reaction to touch, besides making it lighter, it wouldn't do any harm even if it did crash into something or someone.
Not bad. So you could actually work safely in the same workspace as the robot.
Right. And because the robot is now so light, you could easily move it from one location to another.
Wow. So, you could just actually carry it across to the shop floor and train it to load the machines. Ah, but wait a second. But for detecting complex parts, this isn't precise enough.
Well, to simplify the programming, the robot could be equipped with a camera or a 3D sensor so that it could detect the exact positions of the workpieces and choose the best one to grip next.
Yes, yes, of course. And then it might even understand spoken orders.
Hey, why not? Place pump case in workpiece carrier. Hey!
So what is the message of this, of this cobot? Is the intuitiveness, is the plug and play concept of, well, they are 2 actors, but they pretend to be 2 workers in kind of machine shop, and they develop the application in a sort of teaching by showing way, in a safe way, without writing like hundreds or thousands of lines of codes. So this is, the plus of the cobot. But of course, we are just moving ahead. And now, on top of Industry 4.0, we are moving towards Industry 5.0. So this table on the left just clarifies what are the differences between the fourth generation, the fourth industrial revolution we can think about, and the fifth in industrial revolution. It's not only the human-machine cooperation, it's not only the human-robot interaction, but it's a sort of personalization. So the customization is pushed to the level of the individual user. So this is the main difference between Industry 4.0 and Industry 5.0. So this is the virtuous triangle of Industry 5.0. In my humble opinion, the two vertices at the base of the triangle are what the politicians, they like to talk about, because these two words, resilience and sustainability, are very, very sexy, very common among politicians. In my view, the most important vertex is the one on the top, is the human-centric development of technology in such a way to promote the talents, the skills, the diversity, and the empowerment. Okay, so this is the fifth industrial revolution. How does the communication technology favor this fifth industrial revolution? And here I come to the fifth generation of wireless technology, 5G. Now, this is the equivalent triangle of 5G technology. And this time, in my opinion, the most important vertex is the one on the lower left. Certainly, with 5G, we will go faster. We will access the network, and we can handle a wide, just a wide lot of data. So we have an extreme mobile broadband. Also, we can have a massive machine-type communication. But from a robotics viewpoint, and from a control viewpoint, because in the end, robotics and control are just the same field, the most important feature of 5G is not only the reduction of the latency, of the delay, but the fact that hopefully, not yet, probably this will happen with 6G, they say, the latency is a constant. So it's not only a low latency, but it's a possibility that the latency can be constant, and as such can be predicted and compensated. So eventually, not only will we be able to connect a wide set of data which are available in the cloud, but also we can connect robots dynamically, not only on a local scale, but also on a global scale. So this is the main challenge. And I want to show you this video. This is a commercial video. Of course, I don't get any royalties or any fees from Qualcomm. Qualcomm is but they made this video. But I chose this video because the message is very strong about robotics, AI, and 5G.
This is a time of rapid progress, when precision robotics, advancements in AI, and the capabilities of 5G can accelerate innovation, revolutionize logistics, and enhance our daily lives. When robotics, AI, and 5G work in unison, new possibilities emerge. This is the invention age. It starts with Qualcomm. Are you ready to go? Are you ready?
So, what is this invention age? I mean, the main feature of the invention age, as like represented by this video, is the possibility of reproducing the tactile feeling, the tactile perception globally over the network. So, during the pandemic, we learned how to do the smart working, but there was not much of physical smart working. The manufacturing, the production had to be shut down, and we were not able yet to operate machines globally through the network. So we didn't really have yet physical smart working. So if we want to have a network connecting machines and humans globally for real-time control, and also to be able to reproduce the physical, tactile experience remotely, we need some proper interface, we need some proper optical equipment. So what's happening is a sort of transition from the IoT, from the Internet of Things, what we call the Internet of Skills. So the skills is much more than things, because it's not only data. It's not only data to be handled, to be managed in an intelligent way, it's also the possibility of reproducing the human skill, the physical action. And this brings me to the concept of the phygital twin. What is the phygital twin? Is the concept of a digital twin, which is to develop for a physical system. So on one hand, we have the master. On the other hand, at the other extreme, we have like the controller domain. If we are able to perform a sort of bidirectional haptic control with perception of zero delay, so to compensate for the latency, So probably this is happening already with 5G, but the experts say that this will happen definitely at the 6G level. We can have not only an ultra-fast network, not only we can have like haptic encoders, but we can have the physical AI. Here it's like edge artificial intelligence, so it's the possibility of developing intelligent algorithms on a global scale. So this has also an effect in terms of the European funding in terms of the European Union, at the European Commission level, because I was discussing, both Carlos and myself have been acting within the Robotics Association. Carlos Terziero and Federico Secondo have been two of the founding members of the European Robotics Association. What is happening now is a sort of merge between three communities: AI, data, big data, data stands for big data, and robotics. So now we have ADRA, which is the AI, Data and Robotics Association at the European level. And the four snapshots you see are what are considered to be the four pillars of next generation robots according to the work program of the European Commission. Of course, just having like three communities all together also brings a lot of politics and a lot of issues which are not easy to be solved. But there is an agreement that for all the funding at European level, now we have four big pillars. One is the traditional of the intelligent factory, is also the field of agile manufacturing. The other field is non-destructive testing. I'm speaking about inspection and maintenance. So to have this is the original utilization of robots in place of the human, replacing humans in dangerous or expensive jobs. Think about the tragedy of Morandi Bridge, which collapsed in Italy 5 or 6 years ago. This was also because of lack of systematic inspection and maintenance. So what about using drones, using semi-autonomous robots, just preventing the humans to be suspended on cables and to do some sort of maintenance or repair task for civil infrastructures like viaducts, tunnels, bridges? What about the use of robots for gas plant, for oil plant, for refinery, or for big chemical plants, or even we have a group of my former students, they are the robotics group at CERN in Geneva, in which there is a risk of radioactivity in terms of the exposure of the humans to radioactivity and so forth. The third pillar is about healthcare, which is totally to be revolutionized by the use of robots. So during the pandemic, for instance, I've been directing the Interdepartmental Center for Advances in Robotic Surgery in the Polyclinic at the University of Napoli, Federico II, and discussing with the robotic surgeons. During the pandemic, all the training had to be shut down because of the impossibility of the people to travel, the so-called proctors. Proctors is an experienced surgeon that is at one end of the two, there is the console of a Da Vinci as like is a double console. So one is the instructor, the proctor, and the other one is the trainee. So the training had to be stopped. So not only the public health service was affected by COVID, by the overload of patients recovered, but also the training of surgeons had to be stopped because of the lack of physical training. And we have a project in Europe, which is EuRobin. EuRobin is a project involving many labs, which is about AI-inspired robotics. And also we're very active within this context. And the fourth field is robots on the field, untethered, like in the video of Qualcomm. And for instance, one field where robotics is growing a lot is the agri-tech. And also at University of Napoli Federico II, we are one of the competence center, of the national competence center, because of the tradition of not only of the agriculture segment, but also of the food segment. So this is where robotics is going at European level, but I want to just spend the rest of my time more about the concept of robots and humans. And one common stereotype of robotics and automation is that robotics are wrongly regarded as job killers. This is the issue of technical unemployment. In 2017, at the World Economic Forum in Davos, there was a heavy statement that because of robotics and automation, 5 million jobs would be lost. This was, in my opinion, pure demagogy, because each time that we have a new technology, there's a price of time, there's a price to pay, which is a turnover of jobs. But actually, you are improving the quality of work, the quality of jobs. So what are the jobs at risk? This video is taken from Fortune Radar. There is no audio, so I'll spend a few words about this video. I mean, those jobs which are repetitive, which are boring, which are frustrating, will be replaced by machines. But there are other jobs in which, other than replacing a human, you will have some sort of robotic technology assisting, aiding the human. This is the case of health. It's also the case, of course, there is a big fuss about autonomous cars. In San Francisco, we have now Uber robo cars. I think they've been discontinued for some safety problems to be solved. So, like for instance, for truck drivers, like the truck driver does the lane tracking. The truck does the lane tracking, and the driver can take a break, can take a coffee, can go to the toilet. And then, of course, you need legally the driver on board because you have to exit from the expressway and you have to drive into the city and so forth. So, other than thinking of robots as job killers, in the face of some jobs lost, there will be some jobs gained. Amazon made their business 5 times bigger during the pandemic. And there was a report in The Guardian, like a year and a half ago, that Amazon installed 500,000 new robots in their plants, in their logistic lines. And people wrongly thought, according to the Davos statement, that 500,000 jobs were lost. Instead, in the same period of time, Amazon hired 800,000 new employees, new people. So this is, of course, this is the course of new technology. So in facing this kind of issues, there's a new branch of robotics which goes under the acronym ELSE, which is the English preposition, which is the acronym for ethical, legal, societal, and economic issues for those that design, construct, and utilize robots. So other than having robots replacing humans, we should look ahead towards a cohabitation of humans with robots, as long as we will be able to address the fundamental human rights and the moral duties corresponding to them. And again, I was inspired by my teenaging time readings, and there is an author which I like a lot, is Italo Calvino. I think this year, it's 100 years that he was born. Italo Calvino, he was a journalist, and he was the most translated author into the English language. He was more famous in the US than in Italy. And this is an excerpt from American Lessons. American Lessons is a nice book that he wrote, and there is, Spanish, you can understand Italian. I don't think there's a problem in understanding Italian. But as long as you think about some android, your imagination cannot be any different from a sort of anthropomorphic machine. So this is a case of a sort of virtuous circle between life and robotics, because the people working about life sciences, I'm speaking about, for instance, the neuroscientists of the cortical homunculus, or the people working on biomechanics, the psychologists, they look at us, the engineer, the roboticists, as one sort of living lab to test, to experiment their theoretical findings. At the same time, with roboticists, we find inspiration from life science. So this is the case of biomimetics or biomimicry, by the case of bionics, in which we have a biological inspiration, like some of the segments in the video that you saw, like some shape of robots that, other than being like rigid machine, just as like soft robotics, like inspired by snakes, by octopus, by birds, by quadrupeds, by hexapods, and so forth, like insects and so forth. And we should look towards a future where robots become more social than solitary. So this is the concept of the robot companion. And other than replacing humans in dangerous or risky or expensive jobs, robots will enhance human work and life in a number of settings, not only like in factories, like traditionally they were developed for, but also for our homes, for our hospital, for the farms, and eventually also along the freeways with some safety measures. So if we want this to happen, if we want to have robots and humans working together and connected globally, we should have a sort of very open attitude in terms of developing research and contaminating across different scientific fields. The list on the left is by no way an exhaustive list of new emerging areas and of new communities of users and developers that come across robotics, biomechanics, haptics, neurosciences, machine learning, virtual prototyping, animation, surgery, sensor networks, material science. We could add material science, for instance. So I've been in robotics now for 40 years, since the time I started my PhD, like 40 years ago. And I'm convinced that any further finding, any further advancement in robotics will not be in our field. It will be at the crossroads, at the intersection with other disciplines. And so the future developments and the further expected growth of the field will largely depend on a scientific cooperation. And only then robotics technology will become ubiquitous, pervasive, and embedded into a smart environment that we take it for granted. Like these tools now are part of our life. And we don't pay any more attention to the fact that, oh, that's a smartphone, or it's like internet, and things like this. So this is the big challenge of robotics. And I want to end my talk with a sort of a positive message before showing you a final video of what we've been doing. I didn't talk about my own team because we agreed to give a general talk, but nevertheless I have a final video showing what we've been doing in Prisma Lab, which is our lab in the Department of Electrical Engineering and Information Technology. But I want to end with a positive message, and this is a statement by the hell of engineer and artist and architect at the same time, like 500 years ago and even more, Leonardo da Vinci. And I had the honor of writing the new lemma of robotics for Treccani. Treccani is the most famous encyclopedia in Italy, and this is the Atlante Treccani, which is the online version of the encyclopedia. And during the pandemic, I was kindly asked to write the lemma, the voice about robotics, and this is the final, I translated it into English this time, although it's in Italian, the original version, but this is the literal translation of the final paragraph of the lemma I wrote about robotics. I wrote this in 2020, and you certainly remember that 1920 is when the word robot entered in our lexicon, in the drama of Karel Čapek, the Czech writer. So 100 years after the entry of the word robot into our lexicon, the challenge, at the same time the opportunity that the world of research will have to represent, is related to future scenarios in which robotics will become an interactive means. So think about the interaction technology to help improve conditions of life. In this vision, the robot revolution will be able to help us reassess the least artificial feature of our world. So on one hand, we have artificial intelligence, but we are humans. We have the natural intelligence, and the natural intelligence brings along our creativity, our humanity. So let's have the machines do some part of our work. So let's exploit the technology the best, and in this way, we will be relieved by some kind of tedious tasks, and we have more time to express our creativity, our humanity. So this is the positive message I want to share with you this afternoon, just as, about what the future is promising in terms of this cross-contamination among different fields and the proper use of technology beyond the common stereotypes and also the kind of fear of danger of using AI, of resorting. Always be a sort of, this is why I like the human-centric vertex of the triangle of the 5G, of the Industry 5.0. So the final video, you saw in the video, in the compilation I edited, I have a motto, inspirational motto that I'm even quoted, is the keep the gradient. So this is a video which I prepared last year. I was awarded the Engelberger Award for Education last year in Munich. And this is, of course, in robotics, in engineering, we don't have the Nobel Prize, but this is a sort of award which is kind of meaningful. And I was asked to prepare a video which would present myself, but also my team, because, it's never the results, the achievement of one individual. Just all this comes out of a working team. So I let you watch this video, and I'll end my presentation with this video. I was born in Napoli in 1959, which was the year the first industrial robot was made. I did my studies and my whole academic career at University of Napoli Federico II, and I always wanted to reach my goals here.
Napoli is a city which naturally trains to complexity and inspires the people living in the city to develop a spirit of creativity.
Our Prisma Lab has been active in robotics since the mid-80s. We have grown up according to a bottom-up approach, from industrial robots to the level of interaction with the structural environment as in field and service robotics applications. Our dream and our goal at the same time has been to make robots useful and acceptable to humans. Our research work is in three main areas. We have developed bimanual robots and anthropomorphic hands for dexterous manipulation. Thanks to my ERC Advanced grant, we have expanded the team with complementary skills to work on non-prehensile dynamic manipulation and manipulation of deformable objects. We have designed sensorized grippers for handling tasks of robots in supermarkets and retail stores. Both industrial plants and civil infrastructures constitute hostile environments requiring mobile, marine, and aerial robotic technologies. We have developed multicopter drones for non-destructive testing of bridges and viaducts and for aerial cooperative manipulation of payloads. We have designed a hybrid drone which can fly, roll along, and inspect pipes, and an aquatic drone for eco-sustainable reuse of offshore platforms. What is the benefit of these technologies? Reduction of costs and risks. The operator can safely guide a remote robot, which then can execute tasks in a semi-autonomous way. In the field of surgical robotics, we have introduced techniques to provide the surgeon
with enhanced multisensory perception, including tactile feedback, which is still missing in today's commercial systems. We have designed mini hands and tools for laparoscopy, prostate biopsy, and suturing. At the frontier of theranostics, we are developing a new version robot with a dual-arm micromanipulator for one-stop diagnosis and treatment of precancer cells during a colonoscopy. We have introduced the instrument of small-scale experiments aimed at turning prototypes into successful products. While strengthening the cooperation between academia and industry in the various experiments, there will be an added value brought by the project. Another instrument we have introduced is that of the challenges through the exploitation of synergies across all the stakeholders to speed up the process of bringing innovative technologies from research labs to industrial end users. We are also active as Digital Innovation Hub in the European robotics scene. Our research has also had a great impact on education. In the latest few years, at University of Napoli Federico II, we've been observing a constant increase of numbers of master's students graduating in robotics. Thousands of students at universities around the world study robotics from our textbook. The textbook contents are also available in terms of 2 MOOC courses for web learning education. Where is robotics going? Reaching for the human frontier, robotics is vigorously engaged into the challenges of new emerging domains. New communities of users and developers with growing connections to robotics are coming together, and thus our strategic goal should be one of outreach and cooperation with these communities. The inherent interdisciplinary nature of robotics is well captured by the Spring Handbook of Robotics. The handbook received the prestigious Prose Award in the category of engineering and technology, and remarkably, it was also the winner for excellence in physical sciences and mathematics, a true consecration of robotics as a science beyond the boundaries of engineering and technology.
So robotics is my big passion, but as my pals know, I have a stronger passion, which is football. In the sense that, the nice fact of being here in Madrid is that tomorrow I will be with Carlos, with Marco, and probably some others, I don't know, at Santiago Bernabeu. The new Santiago Bernabeu is not yet the renewed stadium. This is a picture I took in 2017 when I was with Marco and his kids and also my kids. And that time I had the official jersey of Napoli. Of course, number 10, Diego Maradona, which is also Io. It's in terms of 1 and 0, I and O. And I had that shirt like Madrid Presente. I hope that the result will be different from that time, because after winning 1-0, we lost and we were kicked out of the Champions League. But, this is like, it's nice to be back. And I was interviewed this morning by, I'm also quite active on the football side. And one radio interviewed me, and I was wishing that we both teams advance, and maybe we can pick Atletico Madrid in the round of 16, so that I can come back to Madrid and see the new stadium of Wanda Metropolitano. So thank you so very much indeed.
Thank you, Bruno, for your excellent and interesting talk. We have time to some questions, to some comments. Please, go ahead.
About football, robotics?
Okay. My name is Milan. I'm part of the telematics department here,
Yes.
where I did my PhD in network robotics, so more on the networking aspect. And I agree a lot with you in this cross-field engineering. I think that that's super interesting. My question is, how much is the robotic field willing to do this? Because for this we need more open robotic field, no?
Absolutely.
How much willing, especially from the industrial point of view, because you've been in the field very long and most probably you know the industrial partners, the main industrial partners, how willing they are for these kind of things to be super open. And second question regarding the sensing part, because you spent some time on it. We have in the teleco world this trend of joint communication and sensing where you can use the radios for sensing. Is there a space for improvement in the sensing in the robotic fields, or the current sensors that are available, they are sufficient and they will not be substituted?
Yeah. That's a very, very good double question. I start from the end. I think the technology of sensors is very well developed, and now we need to work more on the sensor fusion, on merging different sensor information, and also thanks to AI and thanks to learning, I think we can improve the performance of systems using the most advanced sensing technology by techniques like DRL, like deep reinforcement learning. So that's where, I mean, as a control guy, I don't believe in a sort of blind, full AI. So I'm kind of skeptical about deep learning. But just as like, that's why deep reinforcement learning, you use the sensor information at best, and also not only can you use like a big set of data, but also you can learn from experience. So instead of starting from scratch, from blind, then you can use this. So I think it's like each time that, I mean, take for instance the case of a Kinect sensor. Some of the applications before the Kinect were either too expensive or were not at the level of a kind of common use in industrial application. And then I will relate to the first part of your question. I totally agree with you that there's a sort of reluctance by the industry in making, robotic systems, like intelligent systems, just because, I mean, I also give the example, I've been working 7 years now in medical robotics. There, the reluctance is even stronger because of the certification, because of safety issues. It's like, for instance, I mentioned 5G, 5G-enabled internet, but we're not there yet because people don't feel comfortable in relying on a communication channel and operate the system remotely. So it's up to us to make it happen and to understand what are the limits, what are the caveats. This morning we were in one of the labs that I visit. We were speaking about like fault detection. So can we have like a complete faultless system by having some intelligent algorithm to learn from faults and then use the reliable sensor technology? So I consult also with companies, and I agree with you. There is always this kind of skeptical attitude. Instead, they want to develop a sort of like closed solutions without taking the risk of relying on the internet channel. At the same time, I have to say that we have the duties. Also, I want to bring up another example, which I think it's also very much capturing what are the challenges. Next year we will have the first trainees in the School of Surgery to robotic surgery. So we will have the millennials. The millennials, they were grown up with this technology, with soft touch. Now, I'm bringing up the example of robotic surgery. Why? Because take a surgeon of 40-year-old. A surgeon of 40-year-old using robotic technology used laparoscopy before learning maybe robotic technology, or maybe they continue using laparoscopy. With the laparoscopy tool, you have the physical, the tactile feeling, which you don't have now with the Da Vinci, because with the Da Vinci system, you know that you only have 3D vision, stereo vision, but you have to interpret it interpret the images and understand maybe the consistency of some tissue. Now, the old surgeon who operated in open surgery and the ones using laparoscopic surgery, also they bring to the robotic surgery all the experience of 10 years, 20 years doing the open surgery or doing maybe the laparoscopic surgery. So they are ready to use a technology which is only based on vision. So the new challenge is about the millennials. The millennials, they were born and they were grown up in the age of like soft touch. So, and that's why we must be ready to provide them with the most efficient tools to have a sort of immersion into the operating room. Now, if you extrapolate this from the surgical field to the industrial field, it's the same story. You know, I mentioned inspection and maintenance. Now, we have now a project with Tecne. Tecne is the division of Autostrade, is the big company in Italy for systematic inspection and maintenance of viaducts, tunnels, and bridges, in which you must rely on this technology for a simple matter of risks and costs. So, but we must be ready to develop efficient and reliable and dependable systems. Thanks for bringing up this issue, because this was a perfect complement to what I was talking about.
We have time for more questions, please. Please.
Yeah, two there. Carlos and...
Hello, thank you very much. My question is about, because I know that you have a control expertise, but my question is more about the hardware part challenge that we are facing today in order to provide a better human-robot interaction. Because there are, I mean, maybe higher torque actuators. There's also soft robotics. There are a lot of new brands that they exist. So, which is your opinion?
Yeah, I mean, as a control guy, you know, of course, you know, I believe into the power, into the value of active control, because you can also have like passive devices, you know, like, for instance, you can have a wearable robot and exoskeleton, which, I mean, the current commercial systems are all passive. You know, it's based on mechanics. So, but I believe into the value of active control. Now, the problem of active control is the acceptability and the safety issues, because when you have like an active control, who is setting the parameters of an active controller? So you must is it the human? Is it the user? We don't know. So that's a challenge. So I think the recipe is like to work on the mechanical design, to work on material science in such a way as to make systems lighter, because especially, you know, this is not only true for wearable robotics, and at the same time try to make the active control as smooth as possible and relieve the user from the task of setting the parameters, because that's the difficulty of, because an expert control guy can set the parameters for any kind of system. When we do tests in the lab, you know, we know how to crank up the gains, you know, how to just like set the control action. But if you think about a commercial product, this is a different story. So it's that's how I think that, going back to also the previous questions, it's like AI and also the topic of my talk can help. So other than having a pure data-driven system, we should be able to develop hybrid system with a good merge of a model-based and a data-driven. So we have the model-based control action, which is to be enriched by data-driven data provided by sensors. So only then, perhaps, we can try to avoid the metaphor of Charlot with the fully autonomous machine. So these are important concepts. If you are interested, I wrote a paper together with my postdoc, who is an assistant professor. I think it's Robotics Mission Letters, if I'm not mistaken. And it's a nice paper about shared autonomy and shared control, which they seem to the same concept, but actually there are two different concepts, because shared autonomy is the actional planning, but shared control is the feedback. So I would like to address you to, or just write me an email and I can send you. Actually, if you go to the Prisma website, my own paper, I have a sort of a preprint available, which is fully accessible as a PDF file. So you're more than welcome to maybe download that paper in which I address that kind of issue.
José Carlos?
Yes.
Well, thank you very much for this interesting talk.
No questions about football. I was hoping. I kept the slide.
Maybe at the end.
At the end.
No, my question was more related to how, in your vision, and in the next years, how artificial intelligence will combine with robotics, because as we know, and you talked about that in your talk, right now there's like a gap between embodiment and artificial intelligence. I mean, we have algorithms for computer vision for certain tasks, but there's not a real integration between both disciplines. So given the recent advances in artificial intelligence, and I know that deep learning is kind of controversial right now, but I'm curious about what your opinion is for the next year, or what your predictions are.
My opinion is my humble hope that all together we'll be able to develop the interaction technology. That's my, that's why we wrote this provocative comment on Nature Italy together with Antonio, because I think that's what we need. That's what we need. And of course, like AI experts will continue to develop their kind of most advanced algorithms, but in the end, just as like the dream is to build some intelligent machines, physical machines, and then you need to really implement physical AI. We're still in our infancy of physical AI. So there is a whole a whole course of developments to be pursued to make intelligent machines useful to humans. We're not there yet, but now I think at least the two communities which were not talking to each other, now they start talking, and also I very much believe into the feed of other communities, like neuroscientists, like experts of communication, like virtual prototyping, like material science. So I look at the concept of physical AI and robotics as one field where I had the honor this year. This was crazy. I don't know if I have this picture. Probably I don't have. It's like in February, I was invited to a workshop by Pontificia Accademia Pro Vita with a private audience with Pope Francis. So I was in the Vatican on February 20th, and the topic of the workshop was convergent technologies. Very appropriate. And I was asked to speak about information technology. So I met Pope Francis in the private audience. I was introduced, of course, being him Argentinian, I says like, I was presented as world expert of IT. It's like, oh, Università di Napoli, Federico II. He said, sì, Sua Santità, Forza Napoli, Forza Diego Armando Maradona, I said. Yeah. But I mentioned this is like, because like the topic of the workshop was convergent technologies. The funny thing, this was happening, and also I was in the same session, and I spoke after Katalin Karikó, Nobel Prize for Medicine. She spoke about convergent technologies for the mRNA vaccines. It's like, so this was a very interesting workshop. The funny thing is that I did not attend the social dinner because I had to leave and go to Frankfurt because Napoli was playing there against Eintracht Frankfurt for the round of 16. No, but I mean, this is, I mentioned this because it's like, it's the topic of this workshop was exactly on the convergent technologies. This is what will benefit humanity. So it's like, and I'm of course a sort of techno-optimist, as you realize, as long as we can exploit what technology gives us to improve, generally to enhance not only our work, our job, but also our life, without pervading in terms of the social skills, because in the end, probably 2 or 3 years ago, I would have given this talk remotely. It's different when you are physically in the room. So now, I mean, I think with the pandemic we have learned, because my courses now are blended, and the students, the outcome, the performance of the students is much better. You know why? Because they come physically to the class, and they have like the slides, then they have the video of my talk, and also I use the tablets. No longer do I use the blackboard, and also they have like the scratch notes from the tablet. And the performance of the student is improved. So this is one clear example of how to properly exploit the technology and how to learn from the lesson of a world tragedy like the pandemic.
Thank you.
Okay, I will make the final question, Bruno. What will be the prediction for tomorrow?
Draw.
Real Madrid, Napoli?
Be kind to us. You know. Don't let me go. Well, there might be some athletic supporters that they wish that Napoli wins, you know, eventually. No, but I think maybe a draw. Maybe like a 2-2. Like, actually, the game in Napoli, you know, that Real Madrid won, I mean, I think it was a draw in terms of the chances. No.
In any case, we will enjoy. We will enjoy.
I mean, being at Santiago Bernabeu is worth the trip by itself, you know, and also because you know the people in Madrid and in Spain, you know, they have the same passion for football. So it's nice to share this experience with football lovers and football fans like the Spanish. It's funny because last night on Twitter I had a message from a journalist in Valencia. His name is Pipe Olcina. He has contacted me. And then he sent me a message, and he gave a definition of himself which I liked a lot. He wrote in a sort of decent Italian, "Io sono un giornalista spagnoletano." And I like this neologism a lot, you know, spagnoletano. So maybe Marco is a professor of Carlos Terziero is a spagnoletano. It's the first time I never heard before, but I like the way he wrote in this kind of naive Italian, "Io sono un giornalista spagnoletano," because he's fond of Napoli. So he will support Napoli tomorrow.
Thank you very much, Bruno. It's excellent, your presentation, and a lot of new ideas and new topics. Thank you very much again.